Yes.
Yes. Yeah.
Okay. Then I start talking about our evidence-driven model of voting and party competition. Oh, I have an echo. Okay. So the context that I developed this model in is the PACE project, as Bruce has introduced. I'm doing an agent-based simulation of political processes and attitudes. And our approach has been to start with a reference model for one relevant case study that can be evaluated based on available data and expertise. And since we are working together with political scientists from the University of Salzburg, they've chosen Austria as our case study because we have comprehensive empirical data for the demand and supply side, the Austrian National Election Survey for the voters, and the Chapel Hill Expert Survey for the parties. And there's an established radical right populist party in Austria, the FPÖ, the Freedom Party for Austria. And this has been twice in government so far. And the period we are looking at is between the national elections of 2013 and 2017, because that contains relevant political events like the migrant crisis mid of 2015 and 16. The model I've done consists of lots of ingredients. So we have voters and parties that are positioned in a political space. Both the voters and the parties are initialized with empirical data. As I said, the outness study for the voters and CHESS for the parties. And we've defined the political space as joint issues that appear in both of these surveys. We have identified 7 different issues from economy, welfare state, to immigration and society. And the agents are positioned in this political space and interact in there. We also add theories from political science for parties and voter behavior. So parties have different strategies. Voters have different strategies to decide about which party they vote for. And we also have an opinion formation process for the voters so that they can change their opinion on these different issues. Then, as every simulation model, this needs a schedule where something happens in time. So each step, parties decide on their new policy positions, then voters discuss politics with each other, and they get polled so that they decide which party they would vote for if there was an election now. I have some additional slides for these informations. I already told you about the political space, the 7 common issues we identified. Then the voters have demographic attributes and political attributes that we all chose from this Austrian national election study. They have positions on all these 7 issues with up to 3 of them defined as their most important issues. And we also give them a social network. They link with their most similar voters. Then parties have a party program that's also modeled as the positions on these 7 issues, with 1 to 3 of them identified as most important for this party. And all their attributes are initialized from the 2014 Chapel Hill Expert Survey. The party behavior, we use strategies that are defined by Michael Laver and then in another paper by Maus and Scholte. There are quite a long list of possible strategies. In the model implemented, we have the aggregator strategy, where a party adopts the ideological stance of their supporters by moving towards the average position of their current supporters. We have the hunter strategy that starts with a random move and sees if this last move increased the vote share, then they keep moving in the same direction. Otherwise, the party will turn around and move in a new direction that's randomly chosen from the 100-degree arc in front of them. Then there's the classic sticker strategy. That means the party just sticks with the party program, they never change position. And there could be a satisficer, which is not used in the Austria model. We have this opinion formation process for the voters. In most IBMs of party competition that I have seen in the literature, voters have fixed opinions. So once they are initialized in this political space, they don't move. In our model, we thought we are modeling quite a long span of time, like 4 years. Voters will change their opinions. So we are using in this model, I've tried several different ones, a slightly modified version of Simon's model, a multidimensional opinion dynamics model that consists of 2 mechanisms, a mechanism to select a discussion partner and a mechanism to change opinion then. As is usual in opinion dynamics models, the discussion partner is chosen randomly from all voters, but interaction between these two will only happen if their ideological distance is lower than a particular threshold. And this threshold depends on the effective level of the voters and is different for each individual voter. For our model, we use the voters' political interest that we have from the Outness survey to model this threshold. The mechanism to change opinion in Simon's model, you can correct me later, Simon, if I'm wrong there. Voters change opinion on all the issues that are modeled. We thought that is a bit unrealistic, and we thought that they only change opinion on the one issue they are discussing in this interaction. And we're following a different approach there. Then 2 things can happen when 2 people interact and discuss politics with each other. They can either move closer to each other if they agree on the majority of the other issues, so they find a compromise, or they move further away from each other if they disagree on most of the other issues. Then voters have also strategies to decide which party to vote for. Here we rely on a paper by Lau and colleagues identifying political behavior, and they identified 5 different strategies, starting with the classic rational choice, where a voter would compare all parties on all the issues, and we operationalize that as a voter would choose the party that is closest to them, just using Euclidean distance in all the 7 dimensions. Then there is confirmatory, which is the voter decision is heavily influenced by their party identification, and we operationalize that as the voter will always vote for the party they feel closest to, and we have this information from the survey data. There's another strategy, fast and frugal, that only compares parties on important issues, so it's more efficient. Voters don't go to all the lengths of this comparing on all issues the parties, and we operationalize that as that they choose the parties that is closest to them only on their 2 most important issues, and we use a weighted distance there, so they weigh the distance with the importance they give this issue. Another strategy is heuristics based, where the authors Lau and I have just a range of heuristics, but some of them are very close to other strategies. So we chose for this model just following friends' recommendations. And here a voter would choose the party that is chosen by the majority of their social links. And then there's, at last but not least, the strictly effective strategies where no information search is happening. So they just go with their gut feeling. This was, in my opinion, the most difficult strategies to actually implement in the model. And we have operationalized it as that the voters choose the party for which they have the highest propensity to vote. This is also taken from the survey data. We also model some external influences on this system, on the public opinion. because most important influence on change of issue salience in the public opinion is the refugee crisis. The peak happened mid-2015. And we have taken data from the Eurobarometer surveys as a proxy for actual media influence. And this is used to determine which topics voters would talk about when they interact with each other. And in this graph, you can see the sudden spike in the interest of the immigration topic, that is this purple line, in 2015 and 16. We also model the leadership change of one of the parties, the Conservative Party. They got a new leader about 3 months before the election in 2017, who emphasized immigration policy above all else. And we modeled that as an adaptation of the aggregator strategy, where the party takes immigration as one of their most important issues. And the direction of their move is now mediated by the party's ideology. So instead of purely aiming for the center of their supporters. The model is initialized as follows. All the 7 parties are placed according to their party positions, and they are assigned a strategy. So we have assigned the aggregator strategy to the 2 major parties, the SPÖ and the ÖVP, the hunter strategy to the FPÖ, that is the Populist Party, and the sticker strategy to the smaller parties like the Greens, BZÖ, NEOS, and Team Stronach. On the left, you can see the world. It's implemented in NetLogo, the model. So this model world can only show 2 dimensions. I've chosen economy and immigration, but you can choose different dimensions in the model interface to be shown. The voters, we are looking at 1,060 voters from the Outness survey. They are placed according to their opinions with some random noise added, so they are spread out a bit more, and they adopt the color of the party they would currently vote for. We also assign them a mix of strategies. We did an analysis of the Outness data and came up with this strategy mix, where not quite 20% have rational choice, and most people are either confirmatory or use the fast and frugal strategy, and a small number is heuristics based or goes with their gut. Yeah, here you can see 4 of the other dimensions and see that the parties and voters are placed in different positions in this. So on the left-hand side, you can see that the Austrian population is rather left-wing if you think about public spending versus taxes or the welfare state. They are pro having the state giving them some public services. On the law and order, they are more right-wing, as proven that they are more in the upper bit here, because this is the dimension, the Y dimension. And on the society issue, like civic liberties, they are very widespread. We compare model runs with observed historical data. We have these overview of the opinion polls that happened in reality. And as you can see here, over the 4 years that we are looking at between these 2 national elections, when the migrant crisis happened in 2015, mid-2015, I don't know if can you see my mouse pointer here moving around? The FPÖ, that is the blue line here, they gain lots of votes because their stance, right-wing stance on immigration is obviously very popular with the voters. But
Ruth, you'll probably have to speed up a little bit.
Okay. At the end, the Conservatives manage with their change in party strategy to gain the vote. The best model results comes qualitatively close to this with the mix of voter strategies. It's not an exact match, of course, but we come relatively close, and I'm quite happy about that. But the model results vary very much. So we only have a small number of successful runs like this. In other runs, it looks completely different. We've done some analysis. I've done 170 runs in total, and only 11 or 12 of them are actually successful. In this graph here, you can see the successful ones in red and all of them in gray. What is shown is the movement of the Populist Party on the immigration issue. And you can see I could identify that as the most influential for the outcomes in the simulation. And all the ones that are successful in coming close to the actual outcome, the FPÖ adopts a more centrist view during the migrant crisis, which is rather counterintuitive. And then they become slightly more extreme again right before the election, where the conservatives, the ÖVP, can move in and take the vote. I've done also some what-if analyses, what-if scenarios. What if all the voters have rational choice strategy? You can see that is a very stable system. All the runs look the same, basically. I want it here. The SPÖ always wins in these runs, and the Populist Party becomes second strongest party. The migrant crisis doesn't seem to have any impact, but we have to think that this is because the rational choice strategy takes all the dimensions into account with equal importance. So the change in issue salience has no influence. And I also ran a scenario, what if all voters use quick optimizers like the fast and frugal strategy? Here we see quite a variety of outcomes. The migrant crisis has a big impact. The political system seems unstable in some of the runs, where small party movements can cause big changes in voter shares. And this will be due to how the fast and frugal strategy is implemented, that it only takes people's two most important issues into account and weighs them according to this importance. And the importance of issues changes with the interaction of voters, so it has a big impact. Okay, come to the end. The type and mix of voter decision strategies has a huge impact on electoral outcomes, obviously. So what I can say is the usual assumption of rational voters seems unfounded from my experiments. Problem is that only a very small proportion of runs comes qualitatively close to the observed historical data, and this mix of strategies seems to be necessary, but it's not sufficient to achieve this. And in the discussion now, I would like to have your input on how we could improve this model. Thank you very much.
Okay, thank you. If necessary, we'll compress my talk at the end of the hour. Are there any questions? Please somehow indicate, turn on your camera and wave your hand or jump up and down or something.
Okay.
Any questions or suggestions for Ruth?
There we are.
Hello. Well, let me make the start. When I first read about this project, this was when I had to review the paper that you presented at the last social simulation conference, and I was really surprised to find out that what you have done in the past 3 years was very, very similar to what I did in the 1980s and 1990s. But then I stopped this work and only continued about 2 or 3 years ago. My main interest was to find out how a polarization of the electorate can be modeled and understood. For this, I developed a number of algorithms to model the frequency distribution over 2 dimensions, not with the normal distribution, but with the distribution whose function is the exponential of the polynomial up to the 4th degree, which allows for 2 or 3 or 4 maxima. And if you have read some of the papers I sent to Ruth a couple of weeks ago, you may have found out what the additional sources of intuition or knowledge can be when one looks at polarization effects, which is obviously not the case in your project. So one suggestion of mine would be to find out whether you can model the polarization, which I believe has also taken place in Austria. I think this is the main suggestion that I can make, because the polarization effects in countries like Germany, but I think also Austria or Switzerland, are much more graphic in these years than it used to be in the 1960s or 1970s when I first used data from that time. Another suggestion is to find out the correlations between the 7 dimensions that you have. I'm really sure that these are highly correlated and that it might be sufficient to reduce them for presenting results to 2 dimensions, which is much more easy to grasp for people who read it. So far my first suggestions. Maybe I have more later on.
Okay, thank you.
Thank you. Any other questions or suggestions? If not, we will go on to Simon's presentation now. I'm sure some questions might come up later.
Okay. Hello, everybody. Does my microphone work? Very good. Okay, then I'll share my screen. So actually, Ruth's presentation is like the perfect introduction to my presentation, because it's about a very similar topic. So my name is Simon. As you might have understood from the previous discussion, I'm in China, so maybe I'm one of the furthest away participants of this conference. And I want to present you one of my agent-based models, which I call a weighted balance model of opinion hyperpolarization. But before I do that, I think I have to explain a bit basically what, for me, the purpose of agent-based models really is. So in an agent-based model, what we usually want to do is we want to explain a certain macro phenomenon. That is a phenomenon that is basically not reducible to single individuals and that encompasses many different individuals. So a societal phenomenon such as economic inequality, segregation, but even things like fashion trends, and crucially, of course, also political polarization. And we want to do this not with the help of other macro variables, but we want to do this with the help of micro mechanisms. And I should mention that these macro phenomena, so depending on the model, they can be quite what's called stylized facts. So basically, Ruth's model is very much on the concrete end of the spectrum of agent-based modeling, with like real data that the model is supposed to capture. My model is more on the kind of stylized end of this spectrum. So I want to understand polarization in general, but not the polarization of a concrete political system. And yeah, the micro mechanisms that we usually take to try to explain the macro phenomenon, those, in my opinion, they should be optimally be taken from a theory. So, for example, from psychology, from behavioral, or from microeconomics, or from political science, for example, rational choice political science. But sad to say that very, very often in the agent-based modeling literature, those mechanisms are very ad hoc. So basically, they're just invented out of thin air very often and not taken from a well-founded theory. But basically, the challenge is then to kind of tie these micro mechanisms to the macro phenomenon. And this is where the agent-based model really comes in. So in my view, basically, an agent-based model is a kind of thought experiment where we ask ourselves the question, what if individuals in a society would really act according to these micro mechanisms? What would happen? And specifically, would the macro phenomenon that we are interested in emerge from this? So in other words, are the micro mechanisms sufficient to generate this stylized macro phenomenon? And also, is every mechanism, every micro mechanism really necessary to generate this macro phenomenon? So this is what Epstein calls generative sufficiency, and the whole model basically is what Epstein called a generative explanation. So I hope that was not too abstract. So what phenomenon am I aiming at with my model to explain it? So the phenomenon that I want to explain, so in the paper we call it hyperpolarization. We call it hyperpolarization because we are basically aiming at the modeling community. And in the modeling community, in the agent-based modeling community, sadly, polarization is often simply equated with extreme opinions. And usually also most of these models, they only take one single policy dimension into account, or like an ideological dimension. But of course, politics consists of many, many different dimensions. No, like we have debates about inheritance tax, vaccination mandates, gay rights, infrastructure investment, etc., etc. So there's a plethora of different policy dimensions in politics. And if we equate polarization with extreme opinions, then we could draw a coordinate system like this with two policy dimensions. Let's say the y-axis here is pro or contra cannabis legalization, and the x-axis is pro or contra gay marriage. And if polarization is only extreme opinions, then basically if we have four actors, which are here in the corners of this coordinate system, this we would have to call polarized, because these actors, these agents, they have very extreme opinions. But the thing is, in political science, we would not call this polarized, because extreme opinions are not enough for polarization. They are necessary, but they're not sufficient. And what we have to have is also a correlation between different policy issues. And that's the case in this system here. So now basically we have two groups of two actors each at two opposed corners of this coordinate systems, which of course means that now agent stances on cannabis legalization and gay marriage are highly correlated with each other. So and because we wanted to just make it very obvious that there is a difference between what the agent-based modeling community understands under polarization and what we are aiming at, we invented the new term hyperpolarization, meaning polarization in a hyperspace, for this phenomenon. So for hyperpolarization to emerge, there must be extreme opinions, but they also have to be correlated with each other. And once this is the case, of course, in the system, what we see emerging is a left-right political spectrum. So now basically, instead of talking about these specific policy dimensions, we can just call these two agents right-wing and these two agents left-wing, and everybody knows, or everybody can guess what their stance on specific topics is going to be, which would not have been possible, of course, in this system here. But the question then is, so what micro mechanisms could generate this phenomenon of hyperpolarization? And so what we first tried out basically was taking mechanisms that have been well established in one-dimensional opinion dynamics modeling. And so basically all the agent-based models that I'm presenting here, and all of them, the agents are represented as d-dimensional opinion vectors. So an agent basically is equivalent with its opinion vector. So what does this mean? We can see it here in this kind of random initial state. So here we would have three opinion dimensions, d1, d2, and d3, and every agent is just a dot in this space. And this dot, of course, can be represented with three numbers, with an opinion vector, that is. And then, of course, an agent-based model is never static. An agent-based model is dynamic. And the dynamics happening here is that the agents, as Ruth already mentioned, they randomly meet each other, and then they exchange opinions with each other. And that is according to some mechanism. And the mechanism can basically be switched out. So the mechanism comes from a theory, and we can switch it out and see what happens. So the first mechanism that we can try out is the most simple one. It's basically attraction. When two agents interact, their opinions become more similar. But this leads to a very predictable and very boring result. Basically, over a short period of time, all the agents just converge to the center of this opinion space because they just get closer and closer to each other through every interaction. And so basically we end up with this complete consensus in the middle of the opinion space, where agents end up just being neutral on pretty much every topic. And this is, of course, not what we see in real societies, in real political systems. The second mechanism that we could try, and this is a very obvious choice because it has been shown that in one dimension, this mechanism actually leads to a polarized state. And this mechanism is known as repulsion. So repulsion basically means if one agent interacts with another agent which is very close in opinion space, they're still going to attract each other. But if the other agent is further away, then they're going to push each other away from each other. So basically, there is this repulsive negative force that makes people become more dissimilar in their opinions. But what happens is sadly not hyperpolarization. What happens is this state that we can observe here. So in a three-dimensional state, opinion space, we basically end up with 8 different clusters of extremists here. So they are all extreme in their opinions, but they all kind of have a different combination of extreme opinions. And of course, this is also not really what we see in really existing political systems, that we see these clusters of extreme opinions. And it's certainly not what we want to have as hyperpolarization. So in both cases, no hyperpolarization, and we also tried some other mechanisms, and we never basically ended up with our desired state of hyperpolarization. Until we had the idea to take refuge to a very, very old psychological theory, very old but very influential, namely balance theory. And balance theory was invented by Haider in 1946. You might know it in its kind of network theoretical incarnation called structural balance theory. But initially, balance theory was a psychological theory and not a sociological theory. And so balance theory is concerned both with opinions and with interpersonal relations. And this is also, I think, that is quite interesting about the theory and also about our model, that we don't just deal with opinions, we don't just deal with, like, so to say, cold cognition, we also deal with people's relations to each other. So kind of more human feelings, so to say. And both can be modeled in balance theory. And specifically, Haider does this by proposing what he calls triads between an ego, like a person, an alter, a different person, and a specific, what he calls an object, which in our case is a policy dimension. So this is how such a triad looks like. And so we have I here. This would be one person. So the person that this is happening in their minds. J is I's representation of another person. And D is a specific policy issue. And according to Haider, sometimes these triads, these triadic relationships, they can be balanced. For example, in this case, both I and J are in favor of issue D. Like, let's say they are in favor of cannabis legalization, both of them, and they also like each other. So we have two friends who agree with each other. And this, according to Haider, is a balanced triad, a very stable triad. Also something like this, if I and J both disagree with cannabis legalization and they like each other, that also is a balanced triad. Last but not least, if I is against cannabis legalization, J is in favor of it, so they disagree on this issue, and I also dislikes J. This is also a balanced triad. So we like to agree with our friends and we like to disagree with our enemies. This is basically what Haider says, phrased in a simple way. And unbalanced states, of course, are just the other side of the medal here. So if I disagree with a friend, this is unpleasant, and this kind of generates a psychological force towards changing this, either trying to agree with my friend or unfriending my friend. And the same is also if I dislike somebody, according to Haider, it will be unpleasant to me if I agree with this person. So I do want to disagree with people that I dislike. And so in general, there is a tendency to go from unbalanced to balanced triads, according to Haider. But one drawback of the theory is that actually Haider only looked at this kind of binary relations of being in favor or being against, liking or disliking. But of course, what we really want to have to be at least a tiny bit more realistic is kind of continuous opinions and continuous feelings, where we can be a bit more in favor or a bit less in favor or even neutral towards something. And for this purpose, we kind of took Haider's theory as our basis, but we expanded it a bit, and we kind of proposed a couple of mechanisms how balance theory could deal with weighted relations. So for example, in this case here, I is slightly against cannabis legalization, and J is very much in favor of cannabis legalization, like plus 0.8. So opinions would always be somewhere between -1 and 1. So what would be our prediction? What should I's relationship to J, or I's opinion about J, be in this case? So with Haider's basic theory, we can't do this, but what we did is we proposed what we called the signed geometric mean. So basically the sign of this relation, whether it's positive or negative, is determined by the product of the signs of these two relations. So this would be minus times plus. And of course, as we know from elementary school, minus times plus is minus. So we know that this should be a negative relationship. But then how strong should it be? And that's where this part of the equation comes in. So basically the strength of this relation we compute as the product of the absolute of these two, so 0.3 times 0.8, and then the square root of these. So this is also called the geometric mean. And in this case, this would mean that I and J should have a negative relation of minus 0.49 in this case. And so in our model, this is also what agents would do when they meet each other. They basically would compare their opinions, and not just on one dimension, but on many dimensions. So that's what Ruth before mentioned, that may be a bit unrealistic about our model. I would actually have to see how it is if they don't compare themselves on all the dimensions. But anyway, in our model, they do this. And then from this, they basically see whether they should have a positive relation to each other if they agree on most issues, or a negative relation to each other if they rather disagree on most issues. And then once they have determined their relationships, then they will update their opinions accordingly. Because of course now certain opinions could be unbalanced now. Let's say two agents conclude that overall they like each other, but still they disagree on some issues. Basically, both agents would be motivated to change their opinions on these issues and go to a more balanced state. So basically, what we have is this kind of loop. So two agents, if they meet, they would first update their interpersonal attitude towards each other, and then update their opinion vector. And then if they meet again, this, of course, would lead to a slightly different interpersonal attitude, which again would update the opinion vector, and so forth and so forth. And we can also visualize this in this form. So here we have two opinion dimensions. So again, think gay marriage and cannabis legalization. And one agent opinion vector would be represented as this green arrow here. So this agent is quite in favor of both of these issues. And the black arrows show just how agents located on other positions in this opinion space, how they would change their opinion if they were to interact with this green arrow agent. And what we can see is basically that, so there's kind of like for agents that are like in this zone here, in this upper right triangle here, they are kind of sucked into the gravity field of the green arrow agent. Whereas agents that are in the other triangle, in the bottom left triangle, they are kind of attracted towards like this shadow opposite point of this agent. And that's just because when they meet for the first time, they conclude that they somewhat dislike each other, and then they adapt their opinions to disagree more with each other. And then the next time they meet, they dislike each other even more, and so forth, until they end up being completely in opposite positions in the coordinate system. And so I can show you how this looks like if we simulate it now with many, many different agents who meet each other randomly over many different rounds. And again, we look at a three-dimensional opinion space here. So this is the random initial state of the simulation. And so what we can see is that first the agents, they all coalesce towards the middle of the coordinate system. But while they're coalescing, they basically also swerve into one diagonal of the coordinate system, and that's this diagonal here. And the fascinating thing is that this diagonal emerges completely at random. It's a different diagonal in different model runs, but all the agents always align to one diagonal. And then once they align, they repulse each other. So they basically split each other into two different blocks here. So left-wingers and right-wingers. And then they migrate to opposite poles in the coordinate system. And in the end, what we end up with is a perfectly hyperpolarized state where we just have kind of one ideological dimension. All the issue dimensions are perfectly correlated, and all the agents are extreme. So, of course, this is quite nice, but it's still very, very stylized. So people might say, okay, this is quite far away still from real political systems. So to give a bit more support to the micro assumptions of our model, what we did is we also tested this using data from the ANES, and different from Ruth, this is not the Austrian National Election Survey, it's the American National Election Survey. And this survey has the nice feature that it's not only asking respondents for their position on different policy issues, but also what they think the presidential candidates' positions on these issues are. And in addition, it asks them for a thermometer rating of these candidates. So do they like them or dislike them? And so this is a perfect testing ground for our theory. We can basically take respondents' opinions and what the respondent thinks are the opinions of Donald Trump and Hillary Clinton. And from this, we can predict what the respondents' feeling towards this candidate should be. So we have here, our prediction is here the x-axis, and the actual empirically measured thermometer rating is the y-axis. And so if our theory was completely perfect, everybody would have to be somewhere on this diagonal. So as you can see, this is not the case. But as you also can see, there is quite a high correlation between our prediction and the thermometer rating. It's just that what we underestimated is what you could call people's Manichaeanism. So if we really fit this data, then we actually get a linear relation that is kind of steeper than the diagonal, which means that what we predict is not extreme enough. So apparently people hate Trump more than we would predict if they disagree with him, or love him more than we would predict if they agree with him. And the same is true for Hillary Clinton. In addition, Trump just has an overall malus that is probably related to his non-policy issue features. So as we can see, also our theory is not just generating the right macro phenomenon of hyperpolarization if we stuff it into a model. It also works very well with empirical data. And that's it from my side. So you can, if you have further questions, you can either read the paper, it's open access, or of course, I would also be delighted if you would give me your comments as an email or right now in the discussion. And I want to end this with an animated view of the plot that I showed you before.
Mm-hmm. Fantastic. I love the animations here. Could you just type that URL into the chat so people can click on it and see your paper easily? That would be useful. Okay. Fantastic. Are there any questions or comments from anyone?
Sorry to be again the first to comment on.
Okay.
I would have liked the comparison between slide number 7 or the last one that you showed with the video and Ruth's NetLogo model results. The problem that I have is that I think whether it was 6 or 7, no, it was 7. And the first part of 7 was 2 blobs going apart. And exactly. I guess this is the result of the function that you use. In reality, we will have a distribution which is, well, bimodal or trimodal, but the modes are much closer to each other. So would it be possible with your model to generate a distribution which is similar to the one that Ruth showed with the parties, the scattergram? I did, by the way, as you may have seen. But my function is a little different from yours.
It is possible, but the model needs a bit of tweaking in this case. So basically, as we have seen here, I should share again. Sorry. So with the empirical data, basically what we see is that some people actually are a bit more extreme in terms of their love or hate for a political candidate than we would predict based on the policy issues. But not all of them, of course. And so this brought us the idea that basically we could kind of implement this kind of degree of Manichaeanism, like how much people see the world in kind of like terms of black and white, as kind of a modeling parameter. And you can implement it as a global modeling parameter, but more interesting it is actually to say, okay, maybe some people see the world very much in black and white and other people are more differentiated. Maybe other people kind of are more able to disagree without being disagreeable, so to say. So they can recognize, okay, my policy position is a bit different from this person, but this doesn't mean that I have to like despise this person, especially if it's not so different actually, if you only disagree on a couple of issues. And if we have people with this tendency, then if we have enough of them, we end up again with complete consensus because they kind of exert a force that pulls everybody to the middle. Whereas, of course, if you have more Manichaean people, then the model will just hyperpolarize much more quickly and much more radically than before. But now if we introduce a mix of the one type of people and the other type of people, and if the mix is kind of just right, so to say, then what we get is very often a distribution with several modes. So basically, the people with a less Manichaean outlook, the people who can, disagree without being disagreeable, they then converge to the middle, whereas the fanatics, so to say, or the people who have a very Manichaean worldview, they are pushed towards the two fringes, towards the two corners of this coordinate system.
That's great. Klaus, if you've got links...
Sorry?
If you've got links... Sorry, go ahead.
Okay, with this slide number 8, because there are still some people in the middle, but wouldn't it be possible in slide number 7 to make these blobs a little larger such that they meet in the middle instead of having them very far apart?
Yes, that would improve the diagram, but not the facts. Yes, it would make it easier to view, wouldn't it? Yes. Klaus, can you, if you have links to your papers on this subject, if you could cut and paste them into chat, I'm sure people would be really relevant, or a reference, that would be really helpful.
Well, I sent a link to my habilitation thesis to Ruth and 2 recent papers in full. They are not electronically available because for copyright reasons, but Ruth has both recent papers. One is in German, unfortunately, but the longer one it should be understandable for all of you.
Okay, well, if you okay, well, Ruth, maybe if you could post the one that is accessible or in the chat, that would be useful.
Okay.
Right. Any other comments or questions? In that case, I will briefly talk about my model. We're running out of time a bit. If you could stop sharing, Simon, I will try and do this. Okay. Right, and we have... Oops. Okay, so I'll quickly go through this because not so much time. This is some work that's about 4 or 5 years old, a complex model of voter turnout, but it's relevant to this. This was a joint project with people from the University of Manchester. The first lot are social scientists, the second lot are theoretical physicists, and I was the sort of bridge between them. So as they've described, so some models are more simple, like Simon's model, which you're trying to understand what's happening, and some models are more descriptive and complicated, and they're quite difficult to understand. But obviously, eventually, we need some sort of combination between these two, and this project was an attempt to do that. And our approach was to try and stage abstraction. So instead of doing a big jump to a simple model from data and evidence, we stage this by having a complex descriptive model first, which relates to the data and evidence, and then later abstracted that to a simpler model. So essentially the bottom stage was more about representation and the second stage about simplification. So what's this complex model? And it's mostly the complex model I'm going to talk about. What's it for? Well, if it's firstly was a sort of descriptive model, integrating lots of bits of evidence to try and produce a coherent picture. Then it was used as a counterexample to a commonly held assumption in the political science field, namely that mobilization by political parties can cause a cascade of interest in the electorate. They mobilize someone who then mobilizes someone else, etc., 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 to vote. And thirdly, to look at some of the reasons why mobilization didn't happen as a cascade. So this is a very complicated model. It looks a bit like on the right-hand side. So there are a 2D range of space representing geographical space, and each square is a household. In each household, there are a number of agents who are members of that household. They have a number of attributes and, of course, a memory of past events. So there was underlying data about the population composition, which we used to initialize and the model. So we had the demographics. So we had people being born and dying and forming partnerships and having kids, etc. On top of that, there was a social network formation and maintenance based on the principle of homophily. Then there was influence via the social networks between agents, mostly about how interested they are in politics. And there are 4 different kinds of social network, which I'm not going to go in, and all of that influenced the voting behavior. So, okay, so yes, we're going to go to that. A brief summary of the micro level causation. It's quite complicated. One of the main things is this loop around political interest level. If you have more conversations and you remember them, you're more likely to be interested in politics, and that affects whether you actually bother to listen or have conversations about politics. There are other things that might affect your level of civic duty, which might affect your voting intention, but there are other things that might affect your voting intention, such as habit and rational considerations. Don't really have time to go into all of the details. So I can only give you a brief flavor here. Like Ruth's model, each run was not deterministic, and like Simon's model, if you ran the simulation with the same parameters, you get slightly different results. And for some settings, you get very bimodal results. The turnout level can be stuck in a high or low regime. So here's each line here is a different run of the model with the same parameters at the start out. They start out with a median level of turnout, so about 45% of people who can vote voting. And then over time, you might either go to a low turnout regime or a higher turnout regime. The zigzags aren't significant. They're just due to the fact that after an election, some people who did vote drop out, they die from the electorate. So it goes down until the next election. So the next results average over many runs, so they appear very smooth, but if you look at individual runs, they're not. The political scientists were interested in this level of mobilization, and they wanted to know the possible impact compared to other influences. So to start with a very basic set of results, here's the average turnout over time with respect to different levels of party mobilization. This is where the parties are phoning people up and trying to persuade them to vote. So at a low level, there's some increase in the turnout, but you get higher levels of turnout with the high mobilization. But over time, whatever you do, it becomes not so much difference, and they tend to drop down in this model. Here we're comparing different levels of mobilization with two different levels, 0% or 20%, with different levels of social influence. This is how often, this is a parameter that controls how often people talk to each other and influence each other about politics. And you can see a variety of things. Here, the 0% mobilization is this line. Whoops. I don't know whether you can see my cursor. This line, and this line. So you can see those three bottom lines are the 0% mobilization. And then if you have higher these two are the middle ones. Then these two italic ones are the medium level of social influence with higher level mobilization, and the highest level, which is a combination of high mobilization and social influence. This shows the pattern of how mobilization would increase with increasing social influence, but also if you do have some mobilization, how social influence may affect the voting levels, and then the social influence has less effect, because you get those sort of pattern you saw last time. Now, of course, what's interesting is why this happens. And because it's an agent-based modeling, we can drill down into the minds of the agents and try and find out what was happening and what were their various different motivations for voting. So civic duty was one of these things in this model, but we can see that 0% mobilization and 20% mobilization had very little effect on civic duty. Civic duty is very important in this model. It's one of the long range effects on voting, but in this case, mobilization didn't make much difference to civic duty. It did make some difference to the rational consideration, but that was very short time. Rational consideration is when you base your future voting on whether the party you wanted to get in did get in. So if you vote for a party and they get in, you feel more happy about it and vote for next time. But if you vote for someone and it didn't, and the other people got in, you are more disinclined to engage in politics. And the two ones that are really increased by mobilization or not mobilization are habit. Habit is thought by the political scientists to be one of the biggest factors in whether you bother to go out and vote. You do it just because you did last time and because you did it the last time before. So we had this very complicated, what I call data integration simulation model. And then we went through some phases where we modeled the model with a simpler model. So this simpler model done by physicists had to agree in results with the more complicated model, but they could throw out all sorts of stuff. And then they tried to see what was necessary in this complex model and what was not necessary to reproduce the results. And then, of course, being physicists, they didn't stop this process until they ended up in a nice mathematical model, but I'm not going to talk about those stages. One of the things they found out was that in this model, whether you had household immigration, so you had immigration of whole households, or whether you had individual immigration, makes a difference to the level of turnout. In general, immigrants increase the level of political participation in the population because they're more interested in politics than native British people. But if you had individual immigration, it increased the level of turnout less than when you had whole households migrating. And the other fact turned out was the social network in this model tend to be very sort of what's called a caveman network, where you have little groups, but with small connections between them. And that turned out to be important for the results. If you just have a random network, you didn't get the